Hey everybody, this is Dean and welcome to Photo Blue. Today I thought I would discuss depth of field and give a practical explanation about it. And by a practical explanation, I mean I will discuss some technical aspects of depth of field and what affects it and how it's calculated. But also I'm going to give you some practical guidelines of how you would use it in the field and in your photography in general terms, because typically there's no reason to use an equation or a program to calculate out what your exact depth of field is going to be. And typically when you're shooting, there's not really the time to do that in most cases, depending on what you're shooting. So let's get started. What is depth of field? Depth of field is the range of distance where an object in or the subject of a photograph is in acceptable focus. The key here is acceptable focus, and we'll go into this more later because there are different objective and subjective definitions of what acceptable focus is. So it's important to realize if you're using a program to calculate depth of field or an equation that it may be using a definition of acceptable focus that may be more or less than your definition of acceptable focus. So that's just something to be aware of. There are many factors affect depth of field, including lens optics, sensor size, and the perception of what is in focus, which I alluded to just before. And we'll discuss more about the perception of what is in focus as well. The perception of what is in focus doesn't really affect the calculation of depth of field, but it affects the way you perceive the depth of field in at least some photographs, or it could. So it's a valid thing to discuss. Factors that affect depth of field: distance, aperture, which is the size of the opening in the lens, focal length, sensor size, circle of confusion. The circle of confusion is the criteria of acceptable sharpness used to define the depth of field. So basically, I'm going to explain circle of confusion a little bit more, but all you need to remember is it's basically in formulas that calculate depth of field, the circle of confusion is usually it's basically like a constant that's based on sensor size. So each sensor size has its own constant that is used for the calculation. But each sensor size not only has a constant that's used, but there are several different standards of what constant is used. So even the constant is not constant, if that makes any sense. And then perception of what is in focus. So there are different things that affect this. Circle of confusion is related to the perception of what is focused, because circle of confusion tries to make a more objective view of what is in focus, or a more standard view of what is in focus, at least as far as calculations go. Okay, the first variable, and one thing to bear in mind is these different variables we're going to talk about. There is some controversy whether they actually directly or indirectly affect depth of field, but practically you can think of each one as affecting depth of field in some way. And as I go through them, I will mention if they indirectly affect it. In this case, distance directly affects the depth of field. The closer the distance, the shallower the depth of field. The farther the distance, the deeper the depth of field. At some point, the lens focus includes infinity. So this is where you can get the deepest depth of field possible on a particular lens. So if we adjust the focus so that the nearest part of the depth of field, or the nearest thing in focus, is at a particular number of feet on a particular lens, and the farthest part of the focus, or the farthest part of the depth of field hits infinity, then that's when we get really the deepest depths of field at any aperture. And as we close the aperture down, we may bring the closer part of the depth of field even closer. So that's one thing to bear in mind. Aperture. The smaller the aperture, the deeper the depth of field. The bigger the aperture, the shallower the depth of field. So when you close down an aperture, it actually increases your depth of field. You open it up, it decreases it. One thing to remember, though, is at really small, or the smaller end of a lens's aperture, a lot of times you start to lose clarity. So if you're going for the greatest clarity, even though the smaller aperture will give you the bigger depth of field, it might not be the clearest photograph, because what happens is once an aperture gets down to a certain ratio and a certain smallness, light can actually reflect off of the blade of the aperture inside, and it can cause the picture to be less sharp. Focal length is another thing that affects depth of field. The shorter the focal length of the lens, the deeper the depth of field. The longer the focal length, the shorter the depth of field. So wide-angle lenses have a wider depth of field, and telephoto lenses have a shallower depth of field. Now, this is one attribute that some people say, no, focal length doesn't really affect it, because what's happening is it's really the distance that's affecting it. Because if you have a wide-angle lens, it's equivalent to being farther back with a telephoto lens. So if you moved if you move the camera so that the image size was exactly the same with each lens, the depth of field would be exactly the same. So that's one area of controversy. But practically speaking, if you change your lens, you don't change the position where you're in, because you've changed the lens from a telephoto to a wide angle, so you can get a bigger view without having to step back, or not having to step back as much. And so practically, yes, it does. When you switch a lens and you don't switch position, it does affect the depth of field. Wide-angle lenses have the deepest depth of field. Telephoto lenses have the shallowest depth of field. It's just, that's something that you want to remember. Sensor size is another thing that affects depth of field, but it's also one that a lot of people say affects the depth of field indirectly. Sensor size works in combination with the focal length, because the smaller the sensor diagonal, the shorter the focal length of the standard lens is. So actually the focal length ends up being smaller, and that affects the way the depth of field works, even though both are standard lens. For example, an APS sensor is about one stop depth of field different than a full frame if you have the equivalent lens. So if you had a 30 millimeter lens on an APS camera, that would be within the standard range, or the standard lens range of that sensor size. If you had that and it was set to f5.6, it would be equivalent to f8 on a 45 millimeter lens on a full frame camera. 45 millimeter would be within the standard lens range. It's a little wider than usual because 50 is usually standard, but it's within standard range. I use those two focal lengths because they're easy to calculate. A APS lens or a full frame lens is 1.5 times what a APS lens would be. So if an APS lens is 30 millimeters, like our example, you would times it times 1.5 and you would get 45 millimeters, and that would be the equivalent focal length in a full frame camera. Now we get to the confusing part of depth of field, which you may or may not have heard of. It's something called the circle of confusion. The circle of confusion is a criteria of acceptable sharpness used to define the depth of field. So it's basically a variable, or it's you could consider it a constant because it's usually used as a constant based on sensor size, or you could call it a variable based on sensor size. And there are a few different standards of it. The circle of confusion is the largest circle of blur perceived as a dot or a clear point by a human being, which is a confusing statement, but it has to do with a point of light, or a point. It's at what point it starts to blur or appear to be blurred. Circle of confusion changes with print size and viewing distance, but most depth of field calculators base the circle of confusion off the sensor size. So you'll have the circle of confusion will be basically a constant for a particular sensor size. So that always stays constant within the equation as long as you don't change the sensor size. And most of the time when you're calculating depth of field, you would be calculating it for a camera with a particular sensor size. There are different standards used to come up with the circle of confusion based on sensor size, including international standard, the industry standard, and the Zeiss formula. They are based on the sensor diagonal divided by a constant. So the actual constant within, I guess, the circle of confusion calculation is each one of these standards selects a constant, and then depending on what the sensor size is, it divides that into the sensor size to come up with a number for circle of confusion. All you have to really remember is, and you can mostly ignore circle of confusion, but it's basically a way to come up with a standard metric for acceptable sharpness is what it is, and that's how it works into the equation when depth of field is being calculated. All right, so now we're going to talk about some different guidelines that are and have been used in depth of field. One of them, which you may have heard of, is the 1/3 and 2/3 rule or guideline for depth of field. The 1/3 and 2/3 rule states that in general, depth of field falls 1/3 in front of the absolute focus, or the focus when you're in perfect focus, what's in perfect focus, and then 2/3 behind it. The rule is far from exact and is greatly affected by distance to the subject. So when your subject is kind of a normal standard range, whatever you consider that, maybe somewhere between 20 and 40 feet away, it starts to actually, the third before and the 2/3 after rule actually kind of works at that point, because that's about what the right ratio will be. But as you get closer, you end up with closer to a 50-50 ratio, although there's still probably a little more, a few percent more feet in focus behind the subject, or a little more. The focus behind the focus point is a little bigger than the one in front of it. When you start to get the subject starts to get farther and farther away, or when photographing landscapes, the depth of field gets closer to like 10% in front, and 90% of the depth of field is in back of where you are focused on. Depth of field calculators. Depth of field calculators are a good guideline, but they might not take certain factors into account. So they're more of a guideline. They're not absolute, and there are a few things that can alter the accuracy of their calculation. Depth of field calculators tend to be better for learning or planning than as a field tool. A lot of there's something called PhotoPills that actually has a depth of field calculator in it, and there are a few other apps that have depth of field calculators, and even websites that have them in it. But for practical purposes, those calculators are best just to see what ifs. Like, if I use this lens, what would the depth of field be at this aperture? And so you can use that as a learning tool or a planning tool when you're trying to purchase a lens, or when you're planning on what lenses to take. In the field, generally, you probably wouldn't use a calculator. You would kind of estimate or just look through the lens or through the viewfinder and see what it looks like to you, and then take the picture, and then maybe look at the picture if you were really concerned. So those calculators aren't something that a lot of photographers are always using, but they're a nice tool. Different models of camera and lenses might affect depth of field or the apparent depth of field. Once again, we always have to determine whether this is, a standard measure of focus or apparent measure of focus and such. Camera sensors with anti-aliasing to prevent moire actually blur detail slightly, so that could affect your perceived depth of field because it's blurring it. Lenses are complex and have different models, even of the same focal length. So you might have different lenses from different manufacturers. They're all 28 millimeters, or you might have different models of the same 28 millimeter from the same manufacturer that are designed differently or have different elements in them. They might have flaws that might affect the depth of field or the apparent depth of field in a photograph. For example, lenses tend to have softer focus in the corners, so the focus isn't always even throughout the picture. In fact, lenses actually have a curved focus, and we have a flat sensor. And there are actually patents from camera companies. I think Canon actually has a patent for actually curving the sensor so you get less out of focusedness and less distortion at the edges of a picture. So that's something to bear in mind. There are all sorts of aspects within a lens that might throw off or alter the depth of field that you get from a particular calculation. So finally, the depth of field takeaways. Wide-angle lenses, smaller apertures, and longer distances to the subject increase the depth of field. Telephoto lenses, bigger apertures, and closer distances decrease the depth of field. APS-C sensors and any APS sensor are about one stop less depth of field to the equivalent full-frame sensor and lenses. So a 30 millimeter standard APS lens at f5.6 gets the same depth of field as a standard 45 millimeter full-frame lens at f8. So these are things to consider. So usually you're not going to be using a calculator. You'll just be thinking, I want a bigger depth of field. This is a landscape, so I'll use a wide-angle lens. And you're going to use a wide-angle lens anyway on a landscape. So you will also, you may figure, I'm going to use a smaller aperture on a wide-angle lens, and you may even pick a point of focus within that landscape. So instead of focusing on infinity, you might focus on something that will give you a greater depth of field. In that case, you might actually make a calculation and figure out what how far away you need to focus to get the fullest depth of field. telephoto lenses, bigger apertures and closer distances decrease depth of field. It's particularly true once you get into macro photography or very close-up photography. So when you're shooting these things, if you want like a blurry background, you might go for the bigger aperture on a telephoto lens. But you also might be aware that you want a little more depth of field, so that the focus isn't so critical. So you might step back a little bit, or you might use a slightly smaller aperture to give yourself a little more flexibility with the telephoto lens. So those are some factors to consider in depth of field. And I'm Dean, and this has been Photo Blow, and I'll see you next time. Don't forget to subscribe, share, and like.